This question is from set D, question 38. So here we have a copper ring that drops beside a magnet. The two figures show the positions at different moments, and we want to find the direction of the induced current in the ring as viewed from the left. Okay, so let's see what happens, right? You have a ring, and it's dropping in front of a magnet. The magnetic field lines look like this. So as the ring falls through, as they fall through and enter this magnetic field, it gains a magnetic flux. And the flux is going to be in this direction. So this is the external magnetic flux. Now, by Lenz's law, a current will be induced in the ring to oppose this increasing magnetic flux. So if I want to oppose the increase in the magnetic flux, how should my current flow so that I can weaken the flux? Well, you want to flow in such a way that the induced magnetic flux will be this way, right? So you'll cancel out. So if it wants to induce a north pole that's going this way, then by using the right-hand grip rule, my induced B flux wants to go this way, my hands are going to curl around this way. Now where's my eye? My eye is on the left, so I'm going to rotate the camera now. Right, which direction is this? This is clockwise. So for figure 39.1, the current will flow clockwise. This will weaken the increase in magnetic flux this way. Now let's look at the second situation. So I have my field lines here, and now the ring is exiting the magnetic field. So if it's exiting the magnetic field, what's happening to my external magnetic flux? It's actually weakening, right? It's going from here to here. So this was my original flux. This is my final flux. Do you see there's a decrease now? Now Lenz's law wants to oppose this change again. It wants to oppose the change. So since this is weakening, the current here, we now want to strengthen the field. So you can strengthen the flux. It always wants to do the opposite. So how can it strengthen the flux? It can strengthen the flux by having the current flow in the ring such that it produces a magnetic field that's in this direction. So this plus this will give me this, right? So again, we're going to use the right-hand grip rule. This time, it's going to point to the left. My thumb, which is the magnetic flux direction, is going to point to the left. And I'm going to let my fingers curl around. And again, I'm going to turn the camera to the position of the eye, which is in the paper. And you see now that it is anti-clockwise. So figure 39.1, 39.2 rather, it flows anti-clockwise. So let's look for the option that's clockwise and then anti-clockwise. The answer is C.